Hi. Okay. I'm wearing the traditional outfit that represents Indian culture. And in India, we are still celebrating a festival called as Diwali. It represents the festival of lights. So, wish you happy Diwali, Romania. Okay, so my talk is, related to e-scooter, electric scooter, and it's talk about the how we use hardware implant attack on the particular e-scooter, and we can control that thing. But it requires a lot of physical reverse engineering of the entire e-scooter. So in this talk, we will understand the typical architecture and what are those kind of communication can used in the
Da.
e-scooter.
Așa este,
So
da. O
before
să
we
fac rost să
jump
plătim.
on the
Avem un fan
actual
avalieră.
talk,
Adi o să
what
vorbească
we
după
learned
pauză.
from many
Te rog, te
years,
rog.
like from 2013 till now. So there are a lot of attacks going on related to automotive, nothing but cars and trucks,
Ideea e
right?
că trebuie să facă
So
un demo și are nevoie să aibă mâinile.
there are some news floating around. Talk about the hackers can clone millions of keys from various vendors. Vendors, nothing but I'm talking about OEMs. And there are some apps which can be exposed, and that can be used, or like thousands of cars, how they unlock and everything. This is an internal mechanism, and there are something called the hardware devices with the radio frequency they can use, and they can perform relay attacks. Those kind of news you can see if you type like car hacking or anything about it. As the smart cars grows, like even the e-scooters growing in the market, they come up with apps, and that works on Android or iOS, and that can be hacked and unlock millions of cars. Even we know the Jeep Cherokee and other kind of attacks we saw in the 2015, and even the radio frequency are more vulnerable for radio attacks. So usually you can see these kind of stuff, but you never see about the scooters. So why electric scooters nowadays? So I'm comparing India because we are the number one in the population in the world. So we have a big market in India actually. So in 2013 we have 1.3 million electric scooters, and it's going to be increased by 10 million by 2023. So why people are using electric scooters? Like rising fuel prices in India, at least I don't know about the other countries, but yes. And government incentives, they are giving incentives to whoever buy electric car or electric scooters. Increasing awareness about environmental benefits. For that purpose, government says you have to use the electric cars or electric scooters. Growing demand for personal mobility solution and improving technology with respect to smartness in the scooter itself. So what e-scooter gives the features when you buy e-scooters? These are things are like very common you can find in the electric scooter, like live vehicle tracking, crash and fall alert, geofencing, anti-theft service alert, do not disturb, navigation assistance, last park location, a ton of things actually. So who am I? My name is Arun. I'm a serial entrepreneur, and even I'm founder and CEO of Amynasec Labs from India, and we have office in the Vietnam as well. So I represent India and the Vietnam at the same time. So we are in the research-oriented company. We research in many niche field, kind of automotive, ICS, IoT, telco products, aviations, these stuffs. I'm also co-founder and CEO of Uno Academy. It's kind of product where you can learn a lot of things about the hacks. I'm a researcher personally and trainer for many things. I'm a speaker in the multi hacking conference around the world. Like DefCamp is the one of the thing, NullCon, Hack in the Box, DefCon, and Black Hat, and many things actually. this is my Twitter or X, you can say that, Root Killer, and this is my LinkedIn. So let's start the game actually. So what's the typical architecture of e-scooter? So when you talk about the e-scooter, they have something called as component, external components and internal components. So if you see, they have lighting, power distribution unit, BMS, battery management systems. It particularly comes into the electric scooter. Onboard charger, ECU motors, side stand, cluster, and the USB charger. So there are a lot of things involved in this architecture. So if you see precisely when the e-scooters comes in the market, so nothing but VCU, it's nothing but vehicle control unit. It's connected with ISGCU, that is control unit, the integrator starter generator. It's nothing but the command goes to, canvas message goes to integrated ISGS and it starts the entire motor. And that ISGS come to the battery system and that's how it works. So it has the ECU inside and the final gearbox where you change or reverse and forward, you can say, you can drive the vehicle. So there are two type of architectures now you can see in the electric scooters. First is single ECU system architecture. So it's nothing but we have battery pack which works on 48 volt and they have set of body control unit. We call it as a BCU in that case. And we have telematics, BMS, nothing but battery management system, powertrain, lamp, and CAN IO, that is CAN input and output, and DC to DC converter. The entire zone, it's connected on this single unit, actually. And these are connected to gyro sensors, fuel sensor, vehicle speed, temperature sensor, and the stand sensor. So if you using stand, so your vehicle doesn't work. So this is kind of safety mechanism for the vehicle in that case. There is another called as ECU, multi-ECU architecture system. It's kind of zonal architecture. So in that, we have infotainment system. Now the infotainment system is better than the previous one. Previous electric scooter, they have everything inside. So main control unit, that is MCU, they call it as. They have GPS, GSM modem inside, and they have Bluetooth. So you can see the entire infotainment system, what you see in the car. So nowadays you can see it in the e-scooter as well. So these infotainment systems connected with a lot of IOs like lamp load, powertrain motor control, mirror control, and CAN IO. CAN IO is again the input and output. So these are things controlled from the MCU, that's a main control unit, nothing but infotainment system. So whatever you do, whatever see the events, you can see it on the infotainment system. So in the safety mechanism, what they are going to deal mainly with battery management systems. Or something happened to battery management system, it throws the warning on the infotainment system, and based on the event or warning of the battery management system, the scooter turn on or turn off or in the inactive mode in that case. And again, this infotainment system is connected with to DC converter. So this is the typical architecture, single ECU or multi-ECU architecture in the e-scooter usually you can find. Okay. This is the actual the canvas thing, the framework. In the frame, packet frame, you will see, you'll mainly deal with arbitration ID. So arbitration ID indicates the ID for events, actually, speed, brake, or any warning message, or anything which represent by the arbitration ID. And they have data length code, that is a DLC, based on the 8 or 2 or 3 byte. And we have data and the CRC field and the end of the frame. So this is the typical framework in the canvas. So how they are connected in the canvas network. So you can see the brake sensors, BCM, brake lamp ECU, headlamp, and everything. It's connected on the two wire. So CAN bus works on two wire, CAN high and CAN low. So that CAN high, CAN low represents the baud rate as well. So like 250K baud rate, 500K baud rate. So in that case, you can find some electric scooter works on 250K baud rates or 500K baud rates. So in my case, 500K baud rate works. So if you see the diagram over here, like we have ECU1, ECU2, and ECU3. So in that case, the arbitration ID. So if the like 03, 02, 05 is the arbitration ID. If you want to reverse engineer the entire arbitration ID for what event, so in that case, 2002, it would be the highest priority message. So that means whatever you see when you do sniffing or intercept the entire communication across the CAN bus network, you will see the lowest arbitration ID. That means it's the highest priority message. So it may be for brake, it may be for the safety mechanism. That's how you can understand what exactly the arbitration ID for what thing. So here is some catch over here. So like 03 and this 03, between two consecutive message, there is a timestamp, like the time interval that is 1 second. You can find 500 second and 250 milliseconds over here. So the entire architecture based on the number of arbitration ID and the time which they want to transfer the data actually. So in that case, 250 is the highest one for timestamp. So you can do a lot of attacks based on this timestamp actually. So there are a lot of tools available in the market. So there are some tools are very cheap and some tools, I mean to say cost effective, and some tools are the commercial one. So it goes around $2,000 to $500 to $2,000. Some of things comes in the $30 to $100. So depending on what kind of things. So first, you can see value CAN 3 is from Interpret. It's cost around $350 to $400. And this is USB tin. You can buy it in 35 euros. Same thing you can do actually. The same attack you can perform with the both tool. And this is PickCan. It's again commercial one. So you can use PickCan as well. It's cost around again the $250 to $300. So it's nothing but both three of them use the CAN bus util or utility. CAN bus utility you can use, and you can interact with Linux kernel, and then you can perform ton of attacks. So we found we have the electric scooter. We cannot disclose the name as we have an NDA signed with the OEM, and based on that, we started finding those vulnerabilities. So it's really difficult to find the CAN high, CAN low wires because it's internal architecture. So we remove the front end of the scooter, and we try to find out the CAN high and CAN low wires inside. So nothing but when we say wires in automotive or the automotive industry, we call it as a harness. So we identify CAN high, CAN low wires inside, and we cut that wire in such a way that we attach our tools like here. Here you can see over here, like we have CAN high, CAN low on the tools itself, right? So we need to attach those CAN high, CAN low of the electric scooter wire of CAN high, CAN low. So, and then our tool is the part of the CAN bus network, and we try to find out those arbitration ID messages. We try to reverse engineer. So what we found after reverse engineering, so battery low warnings If the battery is low, there is an event, and because of that warning, it stops your entire vehicle or scooter in that case. Safety and functional issues, and speed and motor safety messages, and ton of things actually. So what we performed attack, we perform replay attack. We record all the messages and replay it. It works. We forge canvas injection. So we introduce a lot of data frames in particular arbitration ID, and it affects on the entire scooter itself. We perform DOS attack. It's nothing but it confused on particular event that could not, perform that particular event. We perform bus up attack, which stops entire canvas network, and the scooter no more in work. And there are different attacks we perform as well along with this. So these are some arbitration ID. We intentionally remove some numbers from the arbitration ID, and these arbitration ID is for some events, such as the first one is if you send continuous message, modified messages result in battery low. If you see the battery low on infotainment systems, you unable to start the e-scooter actually. And again, there are some messages. If you modify it will turn off the entire motor, electric motor in the e-scooter. So there are a lot of things we performed and done reverse engineering. These are the very less we listed, but we found many things. So its talk is related to only CAN bus. We found in the infotainment system, Bluetooth, many bugs. So what's the hardware implant attack? So we reverse engineer the entire communications, and what we do that we try to perform POC. So how can do the remote attack? So the same e-scooter we have in the India and other vendors, other OEMs, same kind of attacks you can perform many e-scooters, because this is the flaw in the e-scooters actually. They're not secure at all. They don't consider security in that case. The messages is not encrypted at all. So same attacks you can perform any vendor. I would say in the Vietnam as well. So the same thing you can perform. The hardware implant attack is nothing but you have to put the hardware in the network of e-scooter, and you can control through the 4G or 3G in that case, and even the Wi-Fi and the Bluetooth. So you can perform those kind of attacks when it's running. So as I said, it's very cost-effective things. We remove first one, the front side of the scooter, and once we removed, we modified, we made some using microcontroller and ESP32 for communication purpose, and we use MCP chipsets for CAN transceiver, and we connected over here. So you can see over here there's two wires are connected. It's nothing but CAN high, CAN low wires, and we inject that message. So we perform this thing on the e-scooter. So let's see the video actually how we perform that kind of attack. So we have the machine which is connected with our hardware implant. We are sending the message, and this is our small lab for everything. And I was driving, and attack happened, and you can see the LED, the front lamp and this thing is no more working. So this is when you send those data. What kind of send data? It's kind of the modified one, and which when you drive anywhere and if you inject those message, it will kill on the road itself. So we perform that kind of attack which can affect on pedestrian and the even with the the vehicle owner in that case. So even in the standby stationary mode, we perform same attack, but with a different ID. So our setup is inside in the scooter itself, and we perform this attack. And once we perform, and you can see it's turn off entire infotainment system and entire motor. So we don't want to show the logo and everything about the OEM actually. That's why we put the sticker. So we need to start the entire scooter again, and then it's restarting entire scooter. So that particular event is like when you send on particular arbitration ID, so it will turn off the entire e-scooter, like infotainment systems and the entire motor in that case. And that happens when you do on, when your vehicle isn't running, same attack you can perform. And so you can see that it's restarting the entire infotainment system. And then it starts. So it's asked for the passcode actually. So this is how the attack is you can perform in the vehicle itself. Oh, sorry, scooter. So conclusion. So still the motorcycle market is huge in the market. So you can name any high-end super bike, they have the same bugs inside actually. Even they need to address the cybersecurity issues in e-scooters, because e-scooters are becoming more smarter. So they have cruise control and everything nowadays coming into the picture. E-scooters are secure, that is myth. So this is like the problem with the manufacturers. They sees that no one can, hack the e-scooters in that case. The same in the 2013, 2015, people said no one can hack the vehicle, right? It's the same way, same in this industry. People say that no one can hack, but it's possible at all, 100% possible. So for that, you have to hire cybersecurity experts from outsider to check the e-scooter from design. And there are some people who works on the safety mechanism. They have standards for safety, but that safety, that cybersecurity expert or hacker or any threat actor can take advantage of that safety and can turn off the entire vehicle, or in the e-scooter in that case. So whatever we saw over here, like the attacks, it's based on the safety mechanism. They made such a safety messages and everything with respect to BMS and the battery management systems and the ECU, but we take advantage of this and you can turn off the engine itself. So safety and the cybersecurity, they have to work hand in hand, hand by hand, or hand in hand in that case. Any questions?
Thank you so much, Arun. We have a question over there. We're going to take 3 questions. Applause in the meantime if you want to.
Thank you.
Hello. Thank you for the presentation.
Just a bit louder, please.
Thank you for presentation. Hello.
Thank you.
My question is, which are the best way to mitigate this attack, in your opinion?
Yeah, so it's very good question. So when we talk about the e-scooter or vehicle industry, the entire architecture systems, when they make ECU, they, in this industry, system, software, and hardware works together actually. So they need to talk with the hardware, and hardware need to talk with us, the software department, and the entire system take care of the entire architecture. So it's like when they design, they have to decide they want to go. I'm talking in general of automotive industry. So they want to go with the automotive AUTOSAR based architecture or non-AUTOSAR. So if it is AUTOSAR, they have SecOC and lot of encryption standards in the AUTOSAR itself. But there is a problem that a lot of industries don't go with AUTOSAR because of expense actually. So it's the same like they want to secure hardware, they go with HSM, right? But the HSM library and functionality caused by the chipset manufacturer, and it's added a lot of cost. So still, if you talk about e-scooters comes in the, I think so, $1,000 to $2,000, and they if really want to secure that communication, they have to think how much they want to invest. So it depends on the what kind of scooter or super bike they are using actually.
So it's all about the money.
All about the money, yeah.
Thank you. Thank you.
Next question. Keep your hand up. Keep your hand up.
Thank you very much for the presentation. If I understood your setup correctly, so you just include an additional hardware which is communicating with your computer so that you can inject the CAN bus messages, right?
Absolutely correct.
Okay. What about the infotainment system itself? Because I pretty much assume that the isolation and the hardening of the operating system over there is not well done, right? So did you also try to somehow inject through the infotainment system?
Yes.
What were your results over there?
We done on the Bluetooth actually. So the system inside the infotainment system in such a way that we don't want to disclose this thing, but I will give you the overview actually.
But we have already seen what the trademark is it, because the boxes were written with the name on that.
No.
Okay, I can show you.
Don't disclose then.
Okay.
Don't disclose then. So the thing is that infotainment systems have Bluetooth stack, and that Bluetooth stack when we first that take action or creates a problem with the messages generates during the, as I said, the safety mechanism message, and that turn off the engines. So it's on the Bluetooth. We done on the telematics devices as well. We first on particular over the air actually, and that's again the created a problem. So overall experience, like yes, the design is not as per the cybersecurity standards.
Thank you very much.
Last question.
So, do you think owning an electric scooter is dangerous for you? I mean, can someone stop it while you're driving?
Yeah, for me, yes, dangerous. But if you see the exact POC, that can be happen. So it might be you're thinking why people go for hardware implant attack, right? So if the attack is targeted, I want to kill someone, I want to attack on someone. So I would understand what kind of vehicle or scooter they are using, and then we try to implement very small hardware in that case, because we've done all the reverse engineering of that particular product, and that can be implanted as a part of that particular vehicle, and you can, create problem. So yes, right now, and maybe in the future, still they are vulnerable. So yes, dangerous for, because if you ride the scooter on the highway at the, like 80 kilometer per hour, if your engine is turned on and you have a vehicle behind, that could be possible that comes to your life. Thank you.